Okay, let us discuss the next problem. This is problem 1.222. This says an artificial satellite is launched into a circular orbit around the Earth, with a velocity v relative to reference frame moving translationally and fixed to the Earth rotational axis. So what they are saying is, so there is a satellite, and this satellite is basically placed in this circular orbit. So there is a circular orbit. There is a satellite that has been placed in this circular orbit. How they place? This is taken here by the rocket. So rocket will come here and rocket will try to launch this satellite into this circular orbit. So how they will do? This is a part of astrophysics. Aerospace, not astrophysics actually. I don't know exactly. Or is a part of astrophysics, or people who are doing aerospace do the same thing, or they are doing the aerospace research do the same thing. I don't know exactly. But I think astrophysics will not be, because in astrophysics people are interested in sun, moon, so motion of sun, motion of moon, motion of stars. So this is a part of aerospace, as I think. Okay, so this satellite has been placed in this circular orbit. Now with a velocity b, I can find what is the phi. So the rocket basically knows with what velocity this satellite has been given or placed in this orbit. So the velocity of satellite in this orbit is known. So v is known. Mass of satellite is also known. This is a Earth around which this satellite is moving. So mass of Earth is also known. And this satellite has been placed at a height h from the surface of Earth. Assume surface is a circular. So total height from here to here is r plus h. Now what the question asks? So let me read. So the radius of Earth and free fall is acceleration of this is also known. So radius of Earth as well as acceleration, that is z, is also known. Find the distance from the satellite of Earth's surface. So you have to find a small h. So what is the h? So very simple. So you have to find h. Z is given to you. Radius of Earth is given to you. So let us do some calculation. Let me give you a hint. You do not have to do anything. And this problem, this is a very easy problem. You have to apply simply circular motion equation. Force is equals to mass into acceleration. Then you will get the answer. So let me wait for 2-3 minutes. Make a pause on your computer and then do the problem. Then we will discuss the answer. Okay, so many of you have done the right. So let us go for the solution part. So you see, now the force on this is, so I will have a satellite. So Earth will basically pull this satellite towards the Earth. So the force is gmm by r plus h whole square. This should be equals to mass into acceleration. So mass of satellite is m. V is the velocity and r plus h, that is the mv square by r. If you cancel, you will find v square is this. Now we have r plus r is known, h is known. I have to find h basically. V square is known, me is known, and z is known. Basically zme I can know in terms of z, because z is nothing but gm by r square. So zme by r square. You have to remember this result. Z is given, so z is nothing but gm by r plus r square. So if you solve this equation, v square is equals to gm by r square multiply by r square divided by r square, you will get this. And now gm by r square is simply a small g, so gr square by r plus h. So this becomes r plus h equals to gr square by v square. If you solve for h, this will be the value. You can write something like this, gr square by v square and v square r. So v square cancels out, so r, if you take r common, so this becomes gr by v square minus 1. So this is the height by which this satellite is moving basically with a velocity v. So this means if I know the velocity, I can find what is the height. So this means if I define that this should be my velocity, so I know at what height my satellite should be launched. So if I know b, means I know the time period of satellite. If I know the time period of satellite, let us say I want to move this satellite in 24 hours 2 times. This means I know what will be the time period, that is a 12 hour. So if I know the time period, I know the velocity. Velocity is 2 pi by omega. So if I know the time period, then I can calculate omega. I can calculate v, because v is equals to r omega. And then from there I can calculate h. Are you getting or not? So if I know v, or you can put v is equals to r omega, where r will be r plus h. From there you can solve for h. Are you getting or not? Even so, this means if I give you V, you can calculate H, or even if I give you time period, you can calculate omega. From omega, you can calculate V, and then you can calculate H. So this is the easy part of this problem. We'll discuss the next problem. Even if you have not written, just wait for some time so that you can read and write yourself in your copy. So make a good notebook so that in future you can refer these problems, because you don't have anything after listening, you will simply have your notebook. So if you want to refer sometime later, you have to see your notebook only. We'll discuss the next problem.